All right. Good afternoon, everybody. So we want to welcome you to today's online event, the Beaver Watershed Alliance Quarterly Speaker Series. Our topic today is all about harmful algal blooms, and we really appreciate you all being here today with us. Also, August is National Water Quality Month, so we're really excited to be able to align with that initiative this month and bring you this speaker series that's all about the rationale behind investing in watershed protection that benefits the future of our entire region. So I'm Becky Roark, Executive Director for the Beaver Watershed Alliance, and the Alliance is a nonprofit group located here in Northwest Arkansas. And our mission is to proactively protect, enhance, and sustain the water quality of Beaver Lake and the integrity of its watershed. We work with a variety of groups to help reduce sediment and nutrients entering our streams and our lakes, which is an essential service to our local communities. So Beaver Lake does supply, it's a drinking water source here in Northwest Arkansas, and it supplies water to 1 in 6 Arkansans or Arkansasiers, depends on what you prefer. But that's nearly 500,000 people here in Northwest Arkansas that depend on this water body for a variety of needs, including tourism and recreation that help support our local economy. So I'd like to introduce our speakers today. We have Brie Olsen, Ecologist Coordinator in the Office of Water at the Division of Environmental Quality, and Dr. Brian Haggard, Executive Director with the Arkansas Water Resources Center. So this presentation is going to cover HABs in Arkansas, including case studies on Lake Hamilton and Lake Fayetteville, and it's also going to cover some harmful algal bloom management plan for Arkansas, including some recommended actions. So thank you all for being here, and for those of you just joining us, you may see some questions pop up over in the chat section as we ask kind of where you're from and how you found out about this today. And if you do want to ask questions, please feel free to do that using the Q&A function at the bottom of your screen or somewhere on your screen. And we'll try to address those questions throughout the presentations. Also, this webinar will be recorded and will be available on demand for a short period of time, but will be on the Alliance YouTube channel here within a week or so. So we want to thank all of you for participating in today's program. And with that, I will hand it over to Brie Olsen to kick us off.
Hello, everyone. Thank you very much for being here today. And thank you to the Beaver Watershed Alliance for inviting me. That's very exciting. So can you let me know if you are seeing my screen?
Yes.
Okay. Okay, so that's working. All right, so I wanted to talk today a little bit about some of the recent history surrounding harmful algal blooms in Arkansas specifically. We'll talk a little bit about one case study. I would love to go on and on about all of the details of the cases that we've been dealing with, but we definitely don't have time for that. So before we really start getting localized, we'll talk just a little bit about what harmful algal blooms actually are. In freshwater, about 99.9% of the time, when you hear about harmful algal blooms, it's going to be referring to cyanobacteria. Cyanobacteria are actually a bacteria, so saying the term harmful algal bloom is kind of a misnomer in this case. Cyanobacteria are photosynthesizing bacteria, so it does make them a little bit more unique than regular bacteria. they can become dominant and prolific in water bodies, and that's when we really start to be concerned about blooms. There are other kinds of blooms that exist in the world aside from cyanobacteria, and they all do have negative ecological consequences occasionally, where they consume oxygen and cause aesthetic problems in our water bodies. But we are really focused on harmful algal blooms or cyanobacterial harmful algal blooms because cyanobacteria have the ability to produce cyanotoxins. It's really important for me to note that just because they can produce cyanotoxins doesn't mean that they always produce cyanotoxins. And if they're producing cyanotoxins, it doesn't mean that they're producing it consistently. So I believe Dr. Haggard is going to be talking a little bit more about the variability in cyanotoxin production. I'm not going to get too much into that, but just recognize that it makes it really hard to manage these things. It seems like, at least to me, I've been hearing more and more about harmful algal blooms in the past decade or so, but they're not really a new problem. They are present in all waters at low levels, and they're a healthy part of the phytoplankton community in pretty much every water body that you're going to find. In fact, cyanobacteria are believed to be the first photosynthesizers ever in the world, so they're billions of years old. They're really not new in the literature either. They were first documented in 1878. But why we're starting to hear about them more and more often is because they do well in certain conditions that are starting to trend upward in our environment today. And that is that they have competitive advantages under high nutrient conditions and high temperature conditions. Unfortunately, we're seeing that start to increase in our environment now. The EPA conducts a nationwide study on the water bodies across our nation. 2012 was the most recent data set that we have available to the public. They conduct one on lakes about every 5 years. So the 2012 National Lakes Assessment, they found that cyanobacterial, the actual cyanobacteria themselves, nothing to do with toxins, their cell density is on the rise. They had increased 8.3% from the previous study. Microcystins, which are one of the cyanotoxins that can be produced, also has been shown to be on the rise from the previous study. They're not necessarily talking about the level of microcystin here, but just that they're detectable in more water bodies than they had previously been. So one of the reasons that this is happening is because our water bodies are becoming more eutrophied or nutrient rich. So in that same study, the 2012 National Lakes Assessment, they found that 35% of the nation's lake have an excess level of nitrogen and 40% have an excess level of phosphorus. When we talk about eutrophication or nutrient pollution, we're really focused more on nitrogen and phosphorus. And so eutrophication can happen in one of two ways. It can happen via point sources or non-point sources. Point sources being those that have a point of origin, are easily traceable, and therefore easily manageable. We have a lot of strategies right now in place to be able to manage our point sources, but we're still working on trying to manage non-point sources. It's believed that a lot of these harmful algal blooms that are occurring now are the result of non-point sources. So let's get a little bit more local. The first harmful algal bloom event that happened recently here in Arkansas was at Lake Nimrod. That occurred in 2014. At the time of sampling, toxins were low. You can see this nice scum in this picture here, but toxins ended up being low. Again, at the time of sampling, we really don't know anything about when we weren't sampling, what concentration did those toxins get to. After the Nimrod bloom, it was expressed that those managing the bloom, those managing water resources would like a more standardized protocol if these events were to happen again. So in 2015, the Harmful Algal Bloom Work Group formed, consisting of federal, state, municipalities, universities, and water utilities. About a year and a half after the work group formed, EPA released draft recommended criteria for recreational water bodies on 2 cyanotoxins, one of these being microcystin, which I mentioned earlier. At this point, they solicited public comment. In the meantime, DEQ had been working on getting a grant from EPA to be able to test for cyanotoxins in-house. A part of this grant was to monitor 6 susceptible water bodies, susceptible based on a history of nutrient loading or a history of harmful algal blooms, Nimrod being one of those water bodies. We partnered with Game and Fish to begin this program, and the reason why we wanted to get this grant was really to start getting some initial data, but it was also to really modify our sampling regime and understand what does it take to sample a harmful algal bloom. But before we even started sampling for the grant that we got to learn how to sample for these, we got a report of a harmful algal bloom on Gillum Lake. So it was kind of a crash course for harmful algal bloom sampling. That growing season, we got 2 more complaints on lakes in the state. All were at fairly low microcystin levels, 1 ppb. It wasn't really a concern, even though these lakes were primary contact. They were below the recommended EPA criteria that were out at the time. That next summer, in June, EPA finalized their recreational criteria for microcystin and for another toxin called cylindrospermopsin. In my experience, cylindrospermopsin is not really an issue here in Arkansas. I have not really measured it in very high concentrations. So throughout the rest of the talk, I'm really going to be more referring to microcystins. If I say something like toxin levels or something like that, I'm talking about microcystins. So remember that that recommended criteria is at 8 parts per billion. The growing season for summer 2019, that was the second growing season that we had started measuring these types of events. We received several more complaints, and it started very early and it went very late. Our first complaint was in February, which typically you don't think of the growing season starting in February, but that's when this happened. Our last complaint was not until the very end of October, so we had a very long season and we had a pretty busy season. But it had kind of been consistent with the previous season where we didn't actually have that many toxin concentrations that were very high. We would see the bloom, there was this visual evidence of a bloom, but the toxins just weren't being produced. There were 2 lakes that did have high levels of toxins, Lake Fayetteville and a dog park in Fayetteville. We got in touch with Dr. Haggard at AWRC, and he communicated with the city of Fayetteville, and I believe they did issue an advisory for those 2 lakes. So with all of the activity that had happened in the summer 2019 growing season, we really wanted to get our harmful algal bloom management plan published on our website. And that's what we did in 2019, December, the very end of the year. So now we are going into this summer with a plan. And so far it has been working pretty well. And then there are some occasions where we find that there are some things that we may need to revise. We started this growing season in May, which is a little more typical of what you'd expect for a growing season. But we got 3 complaints within 2 days, so it was kind of just jam-packed in there. 2 of the lakes that we got a complaint on were pretty consistent with what we'd been seeing. Microcystin levels were low, really weren't that much of a concern. But there was 1 lake that had greater than 100 parts per billion of microcystin. Remember, The EPA recommended criteria is 8 parts per billion. So we recommended that Game and Fish issue an advisory on the lake, and we continued to sample the lake until toxin levels were fairly low for a consistent period of time. About 2 weeks is what we usually try to get. Unfortunately, this did have an economic impact on some of the local fishing shops in the area. We were on a routine lake run in June when we saw that there was a scum on Lake Fayetteville again. The results came back around the same as they had been the year before, about in the 20s and 30s. So we again recommended to Dr. Haggard that he get in touch with the city of Fayetteville to issue an advisory. Later in the month, we got a report on Lake Algal that there was a harmful algal bloom. You can see it in the picture. Dr. Haggard went up and collected a sample and reported that it was about 25 parts per billion. So we recommended that Game and Fish issue an advisory on this lake as well. In early July, we got a report that Lake Hamilton was starting to bloom. Pictures clearly indicated that yes, it was blooming. And so the highest sample that we got was greater than 50 parts per billion. And we're going to talk a little bit about Lake Hamilton. We're going to go into more detail about that, so we'll come back to that one in a minute. Later in July, towards the end of July, we at DEQ received a report that the Poteau River was blooming. Dr. Haggard's group was actually down there for a different study and independently verified that it was blooming. So they have been taking samples on the Poteau River. We currently do have an advisory issued on the Poteau, which is really interesting because we really weren't expecting to get a bloom on a river at this point. These typically happen on waters that don't have a lot of flow. So this is something that we're learning, something that we are hoping to add into the plan when we revise it. So let's go a little bit into the Lake Hamilton case study. On the 8th of July, I received a report that there had been a harmful algal bloom on Lake Hamilton. And I had received some reports from Lake Hamilton before, but the pictures had usually indicated that they were filamentous blooms, which we can't really do too much about filamentous blooms, and typically they don't produce toxins. So I thought that this is what that was again. So I asked the gentleman who would call me to send me a picture, and he sent me the picture that you see here on the slide, and we definitely confirmed that that was a harmful algal bloom. We, according to our harmful algal bloom response plan, once we visually identify blooms, we can go ahead and issue an advisory. And that's because, like I've been saying, these toxins are so variable that just because we go out and sample one day and get a low toxin value doesn't mean that the next day it's not going to be dangerous for somebody to use that water body. So typically we try to issue advisories based on visual confirmation. I immediately started making calls to our lake managers. Our harmful algal bloom response plan really puts the authority towards the lake manager to issue advisories, to communicate with the public, to put up signs, and that's really because here at DEQ, we're centrally located. It's just not easy enough. It's not very easy for us to get out to all of these locations. We really rely a lot on our partners. So we contacted our partners. We were able to get in contact with Game and Fish, but we had difficulty reaching some of our other contacts. On the 9th, Game and Fish collected a sample, brought it back to the lab, which we analyzed on the 10th, and results came back at around 10 parts per billion, which is greater than the EPA recommended criteria. It's not that much greater than EPA recommended criteria, but it is greater. So we continue to communicate those results, or try to communicate those results with our contacts. By Friday the 10th, we still hadn't heard from the contact that we had previously established for issuing advisories and for posting signs. And we had been getting a lot of calls from the public. We were starting to get a little bit concerned that people were being exposed to the bloom without really being aware of the potential risks. So at that point, we had decided to submit a press release regarding the situation on Lake Hamilton. And this is not the whole lake. It was a small cove, Little Mazarn, if you're familiar with it. I'll have a picture in a little bit just describing the extent of the bloom. But we had not done this previously. We had left this up to the lake managers to communicate with the public. So this was a little bit unprecedented that DEQ was the one to release the news release without really knowing what the position of the lake manager was. But ultimately it comes down to what do we need to do to protect the public. We didn't actually issue a official advisory, but we did issue a statement saying that this is what happens and stay out of the water. We went out the next day, collected samples, and that Saturday, the 11th, is what is shown in the pictures here. And so you can see that this bloom is really wild looking. It was pretty bad. It came back at around 33 parts per billion, so it was increasing. Well, we went out the next 2 days, and microcystins were actually below 1 part per billion. So 2 days of being below 1 part per billion, we figured, okay, well, I guess that was that. We took a little bit of a breather. Toxins seemed to be trending down. And then we got a text from some of the homeowners on the 14th. And it looked like it was back, and it was worse than ever. We also that day received a call from our contact who notified us that the management of Hamilton is actually way more complicated than we realized. There are 4 different entities who own boat ramps on Lake Hamilton. So we had an internal discussion. We figured, okay, well, if at this point, DEQ probably should be the one to issue this advisory. We're the one that's been collecting all of this data. We're the ones that have been taken the pictures, and we probably know a little bit more about this than most others do right now. So we decided to issue an advisory on the 15th, an official advisory. We went out and put signs out at all of the boat ramps all of the public boat ramps. Nobody seems to have an issue with that, so I think that's probably how we may proceed in the future. We also collected a sample on the 15th and found that toxins were higher than they had been previously on any of those other days. They were at greater than 50 parts per billion. So we knew at this point that we really did have an issue out on Lake Hamilton, that this wasn't going away as quickly as we thought it was going to. But at this point, we had submitted 2 press releases, and we had signs up at the boat ramp. So we felt fairly comfortable that people were getting made aware of the situation. We continued to sample weekly. That next week, after we had issued the advisory, we brought our drone team out, and they took some aerial footage of the bloom to get an idea of what the extent of the actual bloom was. We took a sample that day too. Microcystins remained above 50 parts per billion. It's really interesting. I learned that you can really see the bloom a lot better from aerial footage than you can in a boat. So I think that was a really good way to use our drone team. So we were sampling within the past 13 days. We had sampled about 6 times, and each of those sampling events takes a decent amount of time to run the analytical. So we were devoting a lot of time to this bloom. Some of the other things were starting to fall through the cracks a little bit. So we reached out to Hot Springs Utilities and asked for their help, which they very graciously accepted. And so we went out on that next week on the 27th, and trained Hot Springs Utilities how to collect the samples, where we had been collecting samples, what bottles to use, what paperwork to fill out. When we went out there with them, we collected a sample that came back at around 13 parts per billion. And you could see that the bloom is really starting to subside here. It's not that bright fluorescent blue or green. It's kind of starting to look like it's going away, but you know, we had that little moment of time where we thought that it had gone away after collecting samples for 2 days and toxin concentrations were low. So we weren't about to make that same mistake twice. So we continued to sample weekly. Over those next 2 weeks, the Hot Springs Utilities brought in samples. We measured them and they were below 1 part per billion. So with 2 weeks of low numbers, we felt pretty comfortable lifting the advisory. We also felt pretty comfortable with the contacts we had made with the homeowners around the lake. And we knew that if they had seen something that was concerning, they would let us know and we'd go back out and issue another advisory. So a lot of the questions that I kept getting throughout this whole process from a lot of the homeowners was, what caused this? We've never seen this before. And unfortunately, the only answer I could give them was, I don't know, it could probably be a lot of things. It could be that there were nutrients that had been accumulating in that cove for quite a while, and there was something that just pushed them over the tipping point. There are point sources on the Little Mazarn. There are non-point sources on the Little Mazarn. Additionally, Hamilton does have a lot of shoreline development. What I truly think is that it was a combination of all of these factors and just the right weather at the right time. It would be really difficult to actually go back and trace the sources of this particular bloom unless we have a study specifically on Lake Hamilton. And even then, I think it would be really difficult to trace those sources. So whenever I give talks about harmful algal blooms, I really just want to make sure that people know, if you see something like this, please avoid exposure to it, especially when it comes to children and animals. Children and animals, they tend to be pretty indiscriminate when it comes to playing in water. I know I played in some really gross mud puddles when I was a kid. So what's, a little bit of blue or green water? Animals, a lot of the times dogs really get affected by harmful algal blooms because, dogs typically love water when they come out. They tend to lick their fur clean, and so they're essentially consuming concentrated cyanotoxins. If you do happen to find yourself in water that looks like this, or you see, your dog is running through some water that looks like this, look out for vomiting, diarrhea, headaches, or weakness, and go to the doctor and let them know where you were. One thing that we really learned from Lake Hamilton is something that we pretty much already knew, but sampling is pretty resource intensive. So we do rely a lot on our partners to be able to help us collect samples or let the public know what's happening. We're still trying to learn how to manage these blooms. We wrote the harmful algal bloom response plan, but there are still situations that we can't ever really be prepared for until we're in those situations. So if you do see a harmful algal bloom, we have a way to report it. Go to our website in the pollution complaint reports, and there is one specifically for harmful algal blooms. It will come right to me or to a couple others here in our division. Please include pictures, contact information, and location information, and we will do our best to get out there and check it out. And that is all I have.
Well, thank you, Brie. So we do have 2 questions here for you. The first one was, do the lakeshore homeowners know lawn fertilizers are a source of nutrients that contribute to these blooms?
I think they do. They are aware of that. And usually when things like this happen, we try to indicate what the sources could be. I don't know if everybody understands the cumulative extent of fertilizers. And I think that's where having educational seminars like this is super important.
Okay, and have there been any HABs documented in the Buffalo River?
We have found cyanobacteria in the Buffalo River, but like I said, cyanobacteria should be present in every healthy water body, every healthy phytoplankton community. We have not had a bloom of cyanobacteria.
How can private property owners get pond sampling?
We usually try to provide resources. I know the Arkansas Water Resources Center does do some sampling. We don't have just a great way for people to send samples off in the state. I think that's something that's a niche that really needs to be filled, is pond management. But there are several places that you can send your samples, and those are detailed more in the management plan.
Okay, how about one more question and then we'll hand it over to Brian. But for everyone that does have questions, we'll have a little time at the end as well. So one more question is, was there a rainfall event that washed out the toxins in CyanoHABs?
There wasn't really just a big rainfall event that I remember. I mean, we had a couple of small events that came through. The thing about the rainfall event is that it could either wash the cyanobacteria out, the bloom out, or it could bring in more nutrients and fuel the bloom even more. So rainfall events are kind of a double-edged sword a little bit.
Well, thank you for helping to answer those questions, Brie, and your presentation. Your Department of Environmental Quality is such a great resource for the state. And we really appreciate you being here today and sharing this with everyone.
Thank you.
So. Okay, Dr. Haggard. Oh, we can't hear you.
There we go. Sorry.
There you go. Yes.
Too many working parts here. Is it full screen for y'all?
Yes.
All right, fantastic. So I'm going to kind of continue on and focus in on a study that we've been doing at Lake Fayetteville here in Northwest Arkansas. We are collecting a lot of data. I mean, intensive sampling on select dates, but almost every week we're out there at 3 sites along the North Shore measuring microcystin concentrations as well as other water quality parameters. And we're continuing this because back in 2019, and if you saw Brie's timeline, is we found microcystin concentrations above the recreational guidelines of 8 micrograms per liter. And that was on 2 different dates. And when we look at samples from this lake, the big 3 algae are ephemenomazon, microcystis, and anabina. And we continually see those 3, you know, in different levels of abundance, but those are the 3 main algal groups that we keep seeing at Lake Fayetteville when either Russell Rhodes or Brad Austin turn around and take a look at the samples that we're collecting. And so since we found this in 2019, we just kept sampling. And as you can see here, as we saw peaks in microcystin in late May, early June, above the recreational guidelines near the dam at Lake Fayetteville. But then, you know, microcystin dropped down, you know, still at times we had peaks where it was measurable, 2 micrograms per liter, but after that point, it was below the recreational criteria. This is to give you an idea of the 3 sites that we sample. We're sampling just from the shore because that's where a lot of the public access points are. And quite honestly, it's easier for us to just grab from the shoreline as opposed to putting in a boat and taking the time to do that. And and we've continued sampling, as I said, and you can see here in this graph, you can see that you know, things went down, and then we saw this peak again in the water samples. And so what you're looking at here is all those symbols connected by a line. Those are water samples from below the surface. We're grabbing a water sample like right below the surface. So we're putting the bottle in inverted, and then once we get below the surface, we're turning it up and letting it fill up with water. The black symbols that you see at the very top to the right side of the graph with all the individual numbers, that's a surface scum sample. And so what we're doing is we're very intentionally collecting just the water at the surface, like, putting the bottle like just an inch or so below the surface water and collecting that scum. And that's something new that we started doing this year based on some sampling that ADEQ was doing, as well as we were doing when we happened to go ahead and sample the surface scum. We tended to see higher concentrations in the scum than what we were seeing in the water column. And you can see that's the case here. If we would have just continued sampling in the water column in 2020, we saw a peak in microcystin again this summer, but concentrations really only got up to about 5 micrograms per liter. But you can see there all the data points whenever there was a visible scum, we would collect a surface scum sample, and you can see the concentration of microcystin that we've seen there. Everything from, right at the guidelines of 8 all the way up to 96 micrograms per liter of microcystin in that surface scum. But one of the things to remember is we only collect the surface scum right now when we see it. And that's one of the things we're changing is we're just going to routinely start collecting a surface scum sample so we can show everyone the variability in that, because very similar to what Brie was showing for Lake Hamilton is, it's high one day and then it's low, or 1 week and then it's low the next week and then it's back up and then it's gone and then it's present. And so it's really a hard thing to manage. And you see even that variability both in the water as well as what's in the surface scum. All right, so we're going to go through a lot of data slides, and then, at some level, in the interest of time here for y'all, because I know it's already 12:38, I'm just going to focus on some big take-home messages. And so every one of these samples we collect from Lake Fayetteville, we measure chlorophyll A, total nitrogen, total phosphorus on, and that's what you're seeing here. And the green bars that I kind of highlighted the data across these graphs is both of the blooms in microcystin. And what I want you to take home from this is the first year in 2019 when we were monitoring the lake and we saw this, it's like what we saw at this point in time when we were measuring microcystin in the water that's when we had the highest chlorophyll concentrations. We had the higher total nitrogen concentrations and, higher phosphorus concentrations during the spring. And if you slide over to the bloom on the right, if you look at that and you just kind of stay within that green bar, you still see the peak in microcystin in the summer of 2020. It started a little bit later than what we saw in 2019. And if you look at the graph right below that, chlorophyll is still high. It's between 20 and 40, but chlorophyll concentrations peaked like they always do in late spring, early summer, but that's not when we were seeing the toxins. And that's, total nitrogen concentrations kind of peaked at that point in time, and then they decreased. And again, 2020 was a completely different year than what 2019 was. And, if you would have had me predict what was going to happen, I would have said we were going to see the same trend, in 2020, and that's not what happened. And when you look at the dissolved nutrient supply, which is what we're looking at here, again, we have microcystin on the top graph, and then the dissolved supply of nutrients underneath that. and in particular focus on nitrate, which is the graph right below microcystin. When you look at that first green shaded area, when we're seeing the peaks in microcystin concentration, what we're seeing then is we're seeing nitrate concentrations are being depleted from the water. And so what we thought in 2019 was the algae were starting to get stressed by nutrients, particularly nitrogen. That's why they were producing these toxins. And then once nitrate concentrations went down near zero, we're not able to measure nitrate in the water column. Basically, the algae that produce these toxins shifted gears and started focusing on, nitrogen fixation, trying to put energy into getting their own form of nitrogen from the atmosphere. And then you can look down, and ammonia concentrations are highly variable. You see that peak in the winter months where ammonia gets really high because of the lake turnover. You see that same thing with soluble reactive phosphorus concentrations as well. Move over to the right in that second, green shaded area. You can see where the peak in microcystin concentrations in the water are occurring. And if you look down the nitrate, this summer, we did not see microcystin in relatively high concentrations in the samples we were collecting underneath the surface until after nitrate was completely gone. And so this is completely contrary to what we saw the previous year. And now we did see, spikes in microcystin concentrations in the surface scum. And if we would have been collecting the surface scum in 2019, we probably would have seen similar data there as well. Last summer and this summer, we've done a comprehensive sampling across the dam and then upstream, and this is from a boat as well as collecting samples from the shore. 2019 was extremely intensive. That's all the sites that we did there. 2020, due to COVID, you can't have as many people working on a boat together or in the lab in close proximity because of all the safety measures that we're taking. We did a reduced number of sites, and we did, I think, approximately 5 or 6 sites, a few sites across the dam, and then worked our way upstream, collecting water samples. And the thing that we keep learning when we look at this data is that microcystin concentrations, they're just variable. They're variable vertically from the top to the bottom, and they're variable spatially. And there's not a real strong pattern of what we're seeing, at least when we focus on the 2019 data from the lake. And we're just now starting to crunch the data from 2020. And we really haven't even looked at how that looks. If you remember, thinking back to 2019, Brie was talking about the variability on a weekly and a daily basis, and I kind of hinted at that as well. Well, we had one day back in, I think, 2019 where we sampled at 11 o'clock and microcystin was 1 microgram per liter. And we went back to the same site to collect water to send to Alan Wilson down at Auburn University. And we sampled again. And at 4 o'clock, microcystin was 11 micrograms per liter. So even within the same day, in just a matter of hours apart, we saw an order of magnitude change in microcystin concentrations. And so that led us to a little study in June 30th of 2019, where I decided to stay up all night sampling on an approximately hourly basis until I decided I needed at least a 30 or 40-minute siesta in between samplings. And I, backed it off to an hour and a half sampling throughout the middle of the night. And then at 8 o'clock the next morning, I tagged Brad Austin on the shoulder and I said, dude, you're it. I'm out. I'm done. I need to go sleep. But what we found when we did this was, we happened, in later June, when you remember that microcystin concentrations have dropped back down to about 1 microgram per liter or less, and we weren't seeing high concentrations. And so we didn't see any type of what I would call diurnal pattern, from light to dark pattern here. The peak concentration that we saw was near 0.8 micrograms per liter, and that happened, around 10 o'clock, 9:30, 10 o'clock at night is when that happened. but you can see, and so the concentrations are just kind of variable here throughout time. We haven't repeated this sampling. This is something that I would like to repeat. I would like to hand this off to a graduate student who's much younger than I am to stay up all night to do this. But we were probably not this summer, obviously, but the next summer going to look at more, doing some more diurnal sampling to see if there's any patterns that emerge, especially when we're seeing high concentrations, and maybe even diurnal sampling of the surface blooms as well, of the surface. The summer of 2019, one of the things we were really interested in is because this is really new to us, both measuring microcystin and everything we're doing. It's like, what's the variability in microcystin measurements due to sampling, both the lake, subsampling from a specific bottle, and also in terms of analytical variability. So what you see in this graph is the line that says sample is 15 different bottles collected from the lake. The one that says bottle is actually, we subsampled that one bottle 10 or 15 different times to measure microcystin. And then we picked one vial randomly and just measured microcystin 10 times on that vial. And so the good news is analytical variability is low if you're measuring the same vial. So what you measure in this smaller vial, because typically all we do is keep back about 2 mils of sample to put through a freeze-thaw cycle to measure microcystin. So analytically, what's in that vial, our lab and Brie's lab is going to be really good at measuring that. But when you're taking a 1 liter bottle and subsampling it for 2 mils, you've got a lot of variability. When you take repeated samples from the lake itself, you can see here you have a lot of variability, everything from concentrations at 0.5 all the way up to 3 micrograms per liter. We did this again in 2020, and this time we focused on the surface scum, trying to even get higher concentrations. And you can see here, it's like, if we pulled samples from these larger containers that we had done, if we pulled multiple samples from those, we saw everything from 1 to over almost 15 micrograms per liter. If we pulled multiple samples from one bottle after we took that, and keep in mind, we're doing saving about 2 mils each time we're doing this. We see a lot of variability within the bottle. But again, if we just measure the same vial repeatedly, we see low analytical variability. And so this is really a good thing. And so what this has done is this has moved us towards another study where we're looking at how, and we're just now crunching through the data on that to look at how much volume should we set back to freeze thaw? Because we can freeze thaw larger volumes, and will that reduce the analytical variability or reduce the sampling variability that we're having to deal with in the lake? And right now, just kind of guessing, looking, no statistics or anything like that, it really looks like about 20 mils is going to, at least 20 mils is going to be the appropriate volume to save and put through the freeze-thaw cycle to minimize sampling variability. And so that's going to change practice in our lab. And the practice in our lab is following the standard methods from Abraxas, who has the ELIJA method that both Brie and our lab are using to measure microcystin. And so that's going to be a change you're going to see in the water lab, is we're going to start keeping back larger volumes and putting those through a freeze-thaw cycle. One of the other questions that I had is, is when this microcystin is contained within the cells, when it's, intracellular, it's not free in the water. And so what I was curious at is, we were keeping samples back. Almost every sample we collected, we filtered a sample to measure free microcystin, and then we also kept a sample of raw water to measure total microcystin. And you put the total through a freeze-thaw cycle, which lyses the algal cells and releases all the microcystin into the water so that you can measure it. And but I was curious, like in the water, both in terms of what we see in the surface scum and below the surface, how much of the microcystin is contained within the cells versus how much is free in the water. And if you look at the top graph, you can see at low concentrations of total microcystin, you see a lot of variability, and then you can see all of those really high concentrations that we had in the surface scum. So when we're sampling the surface scum, most of the microcystin that we're measuring there, almost, you know, anywhere from 80 to 100% of it is in the cells. It's not free in the water column. But once you start looking at my total microcystin concentrations of less than 3 micrograms per liter, anywhere from 100 to 0% will be in the cells. You know, typically you see most of the microcystin in the cells, but there's a lot of cases, even at concentrations as high as almost like 1.5 micrograms per liter of total microcystin, that we saw almost all of that as free microcystin in the water. And so that's something else that we're going to kind of keep studying and keep an eye on is, you know, is what does that mean both in, I mean, the question is what does that mean both in terms of human health and animal health when the microcystin is contained in the cells versus, you know, free in the water. And so we're going to keep sampling that and keep populating this graph to get a better handle on that. But right now it looks like when you're above 3, most of the microcystin is contained within the cells. When you're less than 3, it's going to be highly variable, but the less than 3 is less than that recreational guideline of 8. I'll run through these slides next, and some of this covers this. And so we did last summer, Baylor University came up and ran some bioassays on the phytoplankton community. And at Lake Fayetteville, looking at how nitrogen and micronutrient availability influence total microcystin concentrations. They came up and sampled after we saw that peak in microcystin concentration. So it's late June is when they came up to sample. So they, you know, it was one of those things where we told them we had high concentrations, and by the time they got up the next week, microcystin concentrations were back down less than 1. But what they did is they spiked it with different levels of nitrogen. And when you look at this complex data, all these graphs here, the take-home message is the more nitrogen that was in the bioassays. And so you have the control, which is the water as is. One thing I will note is that they did add phosphorus to all these treatments so that none of the treatments had phosphorus limitation. So they induced nitrogen limitation that way. And so if you had low, medium, or high levels of nitrogen, and that would be, you know, like 0.1, 0.5, and 1 milligram per liter of nitrate would be the equivalent to those low, medium, and high. What you saw was increased toxin production with increases in nitrogen added to the system. And so when you have these, so if the lake got a pulse of nitrogen, when these cyanobacteria are present, they're gonna be able to produce more toxins than they were if they didn't get that pulse of nitrogen. At Lake Fayetteville, there really wasn't an influence on micronutrient addition, except on one particular form of microcystin called microcystin LA. That did significantly increase when micronutrients were added to these bioassays. And probably one reason that we didn't see that is the limited data we have on, you know, micronutrient concentrations at this lake. You know, they're in the 3 to 10 microgram per liter range, but that's enough. I mean, it doesn't take much of these micronutrients to, you know, provide everything that the algae need. And so we think that the lake's not limited by micronutrients because they're naturally present or present from the anthropogenic sources there in the water. And so, and then this is a paper written by Dr. Thad Scott's postdoctoral research associate, Nicole Wagner, and she just last week, she submitted this to Limnology and Oceanography. And so, you know, we got that data written, they got that data written up and submitted in a timely manner. And with that, I will be glad to take any questions about the research we've done at Lake Fayetteville or any other questions you may have.
So Brian and Brie, there's quite a few questions in the Q&A box. Do you all want to take a look at those and maybe answer some of them?
I'm good with, yeah, answering any questions. Okay. In terms of the webpage where the public can go and see all the warnings throughout Arkansas, that's not something that we have up yet, but we are currently working on putting that together. Hopefully we will have something by the end of the year. So we should have something next year.
Sorry, I was going through and I was reading the question from Adam Comer. His question is, they're down in Texas and they're having issues with HABs as well in their reservoirs. And it seems to be becoming more visible to the public, much like what we're experiencing here in Arkansas. And, with our experience in the region, is this recent trends a result of our awareness in the scientific community, more conducive environmental factors, or a combination of both? I would say, really focused on Lake Fayetteville because I've been in Northwest Arkansas for 20 years now. I think a lot of what we're seeing may have to do with the scientific interest. Now we're out there looking for these problems. But that being said, I think also now the general population is now becoming more aware of what to look for and what to report. And that's why Brie and I are going all over the state to sample different lakes. And, I wish we had data going back 20 years at Lake Fayetteville or some of these other lakes so we could know what the real trends are in microcystin. And so it's hard to say, but one of the things we do know, it's like nutrient enrichment of these systems puts them in a situation that these cyanobacteria can outcompete other algal species. And these happen to be these cyanobacteria in freshwaters are the ones that can produce, these algal toxins. And so I do think that there's definitely some environmental influence as well going on out there as the reason why we're seeing this more and more.
We might have time for maybe one more question.
There's one that was directed at me. It's like, what would be the mechanisms for increased nitrogen to trigger toxin generations? If you're thinking about within the cell, it's like all of these toxins, they're active groups which make them toxic. A lot of those are amine groups on these larger molecules, and some of the molecules require more nitrogen than others. And so really we think if you give the algae some free nitrogen, that's why they're going to produce that. If the question was kind of what's the environmental mechanisms that are going to, provide that increased nitrogen, it's probably, it could be a variety of things. It could be rainfall. The rainfall in our area has 1 milligram per liter of nitrate in it. So a little bit of rainfall can, add a little bit of nitrogen right there. It can also be these, these episodic rainfall runoff events where it pushes nitrogen in from the watershed. And that's what kind of alleviates that. One of the other things we're really looking at Lake Fayetteville too is how much phosphorus is leaking out of the sediments. Because even though we're not measuring phosphorus in the water column, we think that the only reason we're not seeing phosphorus in the water column is because the algae are taking it up so fast that we can't measure it because we know it's leaking out of the sediments.
Excellent. Well, thank you all both so much, Brie and Brian. And we just really appreciate your dedication and passion to continuing to study HABs and keep a watch and be a resource to all of our communities. So thank you all so much for bringing your presentation to so many people today. As a thank you, we do have a lunchbox and a hat we'll send over to you. And just really appreciate your time today, and everybody else as well. So if we didn't get to your question for any reason, we can share a link. Should get a follow-up link after this, and we can share Brie and Brian's contact information. I'm going to just do a last screen share here and just share thank our partners as well for helping to provide these programs, such as the speaker series. Our next opportunity to come and learn is going to be September 24th for a annual symposium. And we have a forest management workshop also scheduled coming up this Friday. A number of things that you can do to stay engaged and involved in water quality work. And just want to thank you. And here's our email and phone number if you'd like to reach out. Otherwise, we'll go ahead and end this program for the day. And thanks again to Brian and Brie.